sometimes more available. Oops. There we go. So number 9 on the related rates worksheet. Oh, another cone problem. So automatically a good question because you know what's coming tomorrow. Water is flowing into a tank in the form of an inverted cone. Again, I don't know which way a cone is correct, but the only way for the shape of the water to stay a cone is if it's that shape of cone or that type of cone. I don't know if that's upside down or not. I mean, like those old little paper water cups, that's not upside down. That's the right way to hold a cone, a snow cone cup, right? So I don't know what's inverted or not, but it's got to be that way. Water is flowing into that tank, having an altitude of 16 and a radius of 4. So the height is 16, the radius is 4. I need to be careful. That's of the tank. Of the water that's in the tank, that's changing because we're adding water to that. So the H is getting bigger and the R is getting bigger as well. Altitude of 16, radius of 4, at a rate of 2 meters cubed per minute. Well, rate automatically means d something dt, and I can look at the units and see m cubed and know that that's volume, or I can read the problem and it's talking about volume. So dv dt is 2 meter cubed per minute. How fast is the radius changing? So find dr dt. And the radius is equal to 2.5 meters. All right, so we're pouring water in. Our tank or our cup, the little snow cone cup, is filling up. So that means H is getting bigger, R is getting bigger, volume's getting bigger. So that's why it's called related rates. All those rates are related to one another. Oops, if we want to back up and think about DTEDs, draw it, translate it. Those usually go together. Got those. Equation. So volume of a cone, 1/3 pi r squared h. Again, I'll give you that one when you need it. I'm not even saying if anymore. When you need that one, I will give that one to you. So I have the equation, but I'm not quite done with the equation, because if I take the derivative now, I can, completely legal, but then I'll have a product rule for one thing, and I'll have a dr dt and a dh dt. So if I take a derivative now, I'm going to make this problem really complicated. It would be nice if I could somehow get rid of the r or the h. Really, I'd like to get rid of the h, because all my problem information is in r. So if there was something we knew about h that we could replace the h, it would sure make our life a little easier. Be careful with that. Yes, h is 16, but that's the h of the tank. The h that we're talking about, and maybe I should have labeled this differently, the dh dt we're talking about is, so that's 16, but this h is changing. So I don't want to plug in 16 there, because h is changing. H is a variable. So only plug in a number if it's not changing. But is there a relationship between h and r? Yeah, 1/4 or 4, depending on which way we're going. But if h is equal to, h would be 4 times r. And because of similar triangles, h is always 4 times r. So in place of h, I'm going to put 4r. 1/3 pi r squared times 4r. So a little bit of algebra, 4/3 pi r cubed. So good with the equation. Now we'll take the derivative. So dv dt equals 3 times 4/3, the 3's will go away, so 4 pi r squared dr dt. And we're trying to find dr dt, which means we need to know the rest of it. R they gave us, dv dt they gave us, so we should be okay to, we derived already, we should be good to substitute and solve. So 2 equals 4 pi times 2.5 squared. And the last one I did a little bit of cleaning up on, so maybe to illustrate that you don't have to do that. We won't do it on this one. dr dt, I'll just divide 2 by all of this stuff. So 2 over 4 pi 2.5 squared. Perfectly acceptable answer. Units. R is a length, so that's in meters for this problem. T is a time. For this problem, that's minutes. So meters per minute. If I go to check my answers, it says 0.0255. So at that point, I would need a calculator to see if those are the same thing. You will have a calculator on this test, but it doesn't do you much good, right? Like, well, all that problem, and the only thing you really need a calculator for is at the very end to turn it into a decimal. And you wouldn't even need to do that on the test. You can leave it like this. So you'll have a calculator. There, I think there is one problem on the test that you need it for, because it's multiple choice and it gives a decimal answer.